Okay, welcome to Lec4, Principles of Programming. My name is Muhammad Hassan. I'm going to be your instructor for this course. But something actually that is not related only to this course, but related to computer engineering in general, that I want to share with you before we start actually about the details of the course itself, is what is computer engineering, right? I know some of you have some kind of an overall idea about what you guys are. You already had like your first year. You already know some kind of programming, I guess, Python, as far as I have been told. But I wanted to share with you what is computer engineering. What is like the big picture before we delve into what is programming and what is C and Java and all of these details, right? So if you look into this picture here, it has all what we call a full stack of computer engineering. Everything you study, if you are a computer engineer or someone that is outside the field, but take something that is related to computer engineering, it will be within this stack. We start with the application, and then it goes down until we go actually to the electronics, like physical layer design, digital design. You will cover all these things if you are in computer engineering specialization. So basically, what I wanted to say here is, you have the application, which is in your mobile phone or your laptop. You open Chrome. Chrome is an application, right? And then you have the operating system that the application is running on top of. What are some examples of operating systems? Yeah? Yeah? Android is an operating system for mobile phones. What else? Someone said Android. Someone has to say iOS, right? For Apple. And then we have Windows, we have Linux, we have so many unfamous operating systems, but these are some of the known names. So what is the purpose of an operating system? What is the function of an operating system? Basically, it's the basic layer that enables you to run applications without caring of what is going on in the hardware, right? When you open your laptop, actually you don't even think whether you have an Intel processor or you have like an AMD processor, right? You just run your stuff. Why? Because you have an operating system that is hiding all these details from you. Good? And also as a programmer, you don't need to care much. You care a little, as you will see later in the course. But you don't have to care much about what is the hardware, because the operating system, as we can see here, is an intermediate layer between the application and all the hardware details. Good? So you have your application, you have the operating system, and then the operating system has some kind of, a lot of stuff. They are what we call linker, loader, scheduler, because you also run not just Chrome. You run like maybe tens, hundreds of applications on the same time. You need to schedule these to make sure that as if they run in parallel for you, right? So the operating system handles the scheduling as well. And then beneath the operating system, you find the hardware. You have your memory, DRAMs, caches, you have your processor, multi-core, single-core, whatever, and then beneath the processor, we have what we call the digital logic design. I don't know if you had a digital logic design course or not yet, but basically these are the basic AND OR gates. Do you guys know what is that? Yeah? So basically this is how you design your processor from the beginning, from a transistor up to a processor, right? So these 3-4 layers here are basically related to hardware. It's part of computer engineering specialization, and as a general user, what you care about all of this is actually the final end product, which is the processor or the memory or whatever hardware you have, right? FPGA. You will get introduced to all of these things as far as you go in your program, but I just wanted to give you like this bird's eye view. So another way to look into this is, you have a problem you want to solve, right? You go to a software developer, like a programmer, tell him, oh, I want to handle this problem. This problem can be anything that's actually very high level. Something like you have a store and you want to make sure that you do your finances correctly, right? You can write a program for that. Or you have a self-driving car and you want to write an operating system for the self-driving car that makes sure that everything is actually satisfying the certification rules or the traffic laws or whatever, right? So you have all kinds of problems that you can imagine, but as an end user, you cannot program. Assume that you cannot write programs for now, right? So you can only specify your problem in bare English, right? You can say, I have 1, 2, 3, 4. I want to achieve these goals. What should I do, right? So you go to a programmer. It takes the the programmer will take the problem from you and write an algorithm for that. Later, you will take an algorithms course. Actually, this course is a prerequisite for the algorithms course. What are algorithms? Actually, you just write programs in a certain way such that the processor or the computer is able to solve, right? These are algorithms, right? And this is a separate course that we'll cover later. And then once you write your algorithm, you can actually write your algorithm in like the pseudocode or like, again, bare English or like simple C, whatever. You can write it in any way. It's just the way you are going to solve the problem, right? It's not limited to a certain programming language. But at the end, you have to implement that, right? So you have to know how to program it. So you have to write a program that implements the algorithm, right? At this point, you need to know how to program, right? And this is the purpose of this course, right? You can learn how to program in Java, in C, in Visual Basic, on whatever, Python, Perl, whatever language it is. At the end, once you will be more experienced in the future, you will discover it doesn't really matter much, right? Once you know one programming language, the concepts are the same, but the targets are different. Good? So you write your algorithm in a specific programming language, and then now I have my program. This is the source code. What can I do with that? Nothing, right? It doesn't execute anything. It's just a source code. You have to compile this, right, into your laptop to have an executable to run. Whatever programs you have in your laptop or your mobile phone, these are actually the executables. You don't have the source code, right? For some programs. For Android, for example, it's open source. You have access to the source code. But in most cases, you only have the executable of the program, right? The thing that you can take and like double click or do whatever and then run, right? This is the executable. How to obtain the executable from the source code, right? This is the function of a compiler, right? So what we do here is after programming your algorithm, you have to take it into a compiler. This is GCC, a very famous open source compiler, or LLVM or whatever, and then the compiler will give you an executable here, right? These are the executables you have in your desktop right now. Good? I have an executable, that's good. What can I do now? You have to have an operating system to run the executable on top of. This is what we started from, right? So this is the operating system that takes the executable, you run, and then the operating system runs on top of what we call instruction set architecture that defines what is the hardware. For example, if you have an Intel machine, your ISA is x86, right? You hear this term a lot. If you have, like in your mobile phone, you have what is ARM V8 or V9. This is the processor that is in your mobile phone, right? And then beneath the ISA, which is just a contract description of the hardware, you have the actual chip itself. It's a multi-core. You have some caches, some DRAMs, whatever is in the hardware, right? So basically, this is a complete picture of what is going on in computer engineering. What is computer engineering about? If you have ever wondered what is this field, or whether you are interested in something but you don't have a big picture, this is basically almost any topic in computer engineering has to be within this big picture. Good? Do you have any question? Good. Okay, so later, I guess once you get more experience, you will learn the picture is actually more detailed than this. For example, to get the executable from your source code through the compiler, you need to know exactly what is the operating system, because the executable that runs on top of Android is different than the one that runs on top of iOS or Linux or Windows, right? So from the same source code, you can actually have different executables based on what is the operating system, what is the targeted operating system, right? And the compiler has to get an input for that to give you the correct executable. Good? At the same time, the compiler also needs to know what is your ISA, what is your targeted ISA's instruction set architecture. Is basically the description of the processor itself. So what is the targeted processor, whether it's Intel machine, whether it's ARM machine, whether it's like Spark machine, right? So you need to have some information to the compiler. And later, again, if you are in the computer engineering field, you will take a compiler's course that will cover all these details. Good? Great. So let's go through step by step here. And then we set algorithms, description of the program. Some of the courses that you may encounter in this block is AI, machine learning, algorithm, software engineering. In general, within this, specifying from a bare English what is the exact algorithm you are going to implement, right? All are actually within this block. Here we have software development or programming, and actually, as you can imagine, 2SH4 is within this block. Good? And then compiler construction or compiler optimizations are example courses that you may have in the future. as like an undergrad or grad, that covers the compiler's block. And then operating systems, for sure. And then some of the hardware things. In hardware, you start with computer architecture or organization. I guess computer organization is third-year course. Computer architecture is fourth-year course. And then you go to digital logic design, which is usually like a second-year course. And then you have computer arithmetic, and like electronics is another example. Physical design, especially if you are in engineering physics, is also a topic in this big picture. Good. Any question? Great. So one thing also to just grab your attention before we delve into the details is, I have given examples from mobile phones and from laptops, right? As you can imagine, these two things are not totally different, right? So if we cover programming, for example, for C and Java, which are most probably for laptop programming, right? General purpose programming, right? You can also write programs in C for Android or for iOS or whatever language it is. So basically the concepts are the same, right? Once you learn how things work in one field, it's actually the same thing in a different picture. Like it's just a different industrial revolution that covers the same concepts. Good? So as you can see here, this is a laptop. It has basically a screen. This is like an output form. Now it's touch screen, so you have input and output at the same time, a way to interact with the user. And then you have the hardware, you have a memory, you have a processor chip here, and you have your keyboard or mouse. These are like input to the laptop as well, right? With the same concept, you actually have your mobile phone, where it's touch screen again, so you have input and output, right? And then maybe you don't have a physical keyboard, but you have the software keyboard, right? It's a different form, but exactly the same thing. It reads some symbols from the input user. Because you press something, you actually encode a certain code to the operating system, telling him that you're actually press F, A, enter, whatever symbol it is, right? Whether this is a physical laptop or like the touch screen, it's the same thing. Right? And then after you input something through your input means, like whether it's keyboard or touch screen, this is going to be encoded into the operating system, execute some sort of a command, run something, and then show you something as an output in the screen, right? So basically the form here is exactly the same thing, but different manufacturing, right? Good. You guys have any question? Yes. Okay, now we'll go away from this big picture thing, and then I don't know if someone else covered this big picture with you before or whether you knew it, but I always find it useful that you always know what is the big picture and why actually this course, how it aligns with the context of the remaining courses, right? And then what about 2SH4? I'll be your instructor. Basically, this is my personal email address, but I advise you not to use this email address for the course logistics because I don't know if someone tried to contact me already or not, but you will not get a prompt response if you email me through my personal email because I have so many other emails and things go to the junk and all these kind of things. So don't try to use this email, right? The thing that you can use to make sure we are organized enough, given that we are around 300, is we have an email for the course itself, right? We are going to have these slides, so you don't need to write anything. It's Combenge 2SH4. You should get a prompt response from this email within 48 hours. If you didn't have that, then you can email me, forward me the email that you sent to 2SH4, like the Gmail account, and then let me know that you didn't get a response within 2 days, right? Then I can do something, right? But this always will be your first mean to contact either me or the TAs, right? And I do my best to make sure that you get a response. For office hours, I'll post this in Avenue. The course page in Avenue will be ready tomorrow, I guess, and I'll upload all the slides there, so you don't need to worry about this. This is my office, and this is the web page. My interests are generally computer engineering, computer architecture, systems on a chip, embedded systems, safety critical systems like self-driving cars, and these kind of things. So basically, I'm more of a systems guy, so I do programming and hardware at the same time. For TAs, we have 11 TAs for the course. You have enough support for you. More details about their emails and contacts will be on Avenue as well, because this list may change slightly today or tomorrow, but generally these are your TAs for this course. For the course, we have 3 one-hour lectures per week, and we have a 3-hour lab session. This course is centered, this is a programming course, so it's actually a practical course. As you will see, the lecture is servicing the lab, not the other way around, right? Because if you don't have hands-on programming, you actually didn't do anything. I'm not here actually to teach you that, like int is integer, like 32 bits and this kind of thing. These things are written in the book and like in slides, and you will learn them, and you don't even need to memorize these. I'm here to teach you how to program, right? And this is very important to know, because if you don't have hands-on on this course, first of all, you will not do very well, which I don't think you want to. But the second thing, you will not get the benefit of the course itself, right? Programming is very important right now, almost for any engineer. No matter what is your field, you are going to program somehow, right? I worked as a purely hardware engineer for Intel for like almost 2 years, and 80% of my work, I was purely hardware engineer. 80% of my work was just programming, right? So programming is not just for software engineers, it's almost for everyone. Even if you are doing some pure hardware or some mechanical work, it doesn't matter. Maybe you want to automate something. You want to write a script to automate your job, right? Or to help you memorize something. So at some point, I grant you in your future, at some point, whatever your specialization is, you have to write a program somehow, right? So catch the chance and learn from this course how to program. And I'll do my best to make sure that I cover the concepts rather than focusing on what are the details of C and Java. We have to write in something at the end, so we'll focus on whatever 2 languages we cover in this course, C and Java, but the concepts, again, are the same. Right? We will not start labs until the week after next week, which is starting September 17th, I guess, or 16th. And the reason for this is we will not have enough material to go to the lab and enable you to do something, right? So I want to cover enough material to make sure you guys have enough knowledge to go and, enough confidence to go and write a program in your first lab. Good? So labs, you have a relief from this until the week after next week. And then in total, we have 5 lab sessions, and the lab accounts for 30% of the final course mark. This is only for the lab thing, but again, in the final, you will be writing programs. In the midterm, we'll be writing programs. So everything is almost about writing programs either in C or Java. We also have a 1-hour tutorial session per week. This is on Friday. And the purpose of this tutorial, again, to service the lab. So we'll be covering some examples, give you some hints about how to do the lab. Either me or the TA will be doing the session. But basically, what will happen there is prepare you for the lab, give you some examples, answer some of your questions. So make sure you utilize this as well. Any question? Yeah. Not this week, next week. It's a good question. So I have to add this to the slides, but basically tutorials will start the week before the lab. So it's next week. Good. These are some kind of logistics. We have 10 sections for the lab. You do the lab individually. So you guys are divided into 10 sections. You have to know your section, and you go only for your time with that. Make sure you don't go to other sections unless you got a permission from me, because otherwise things will get messy, right? Good. For the assessment, we have 10% for quizzes. Quizzes will be on lecture. So basically, what I'll be doing is while lecturing, I'll stop for 10 minutes, maybe in the middle of the lecture or at the end, and then tell you to open your laptop. And then this is written in the outline, but I don't see you guys have your laptops. That's okay for the first lecture. Usually, come to the lecture with your laptop. This is again a programming course. So you will be focusing on doing things, right? Not just sit and listening to what I'm saying, right? The quiz will be very easy. Just a quick question. These are not free marks, but they are almost free. So make sure you catch them. You get your laptop. You do whatever simple problem or simple assignment I'm telling you to do on the slide, and it takes 10 minutes, and then you upload this to Avenue, and that's it. Good? Any question regarding this? This is not meant to be tough for you or stress you during the lecture, so take it easy. It's just meant to be make sure you have enough attention during the lecture, and make sure you get some marks from learning something new in the lecture, right? So it's, as I said, these are not free marks, but they are very easy to get. So make sure you catch these. Don't feel stressed because of that. Again, this will be marked based on your knowledge. So the question most probably will be related to the lecture that we are doing right now. So lecture 1, in the middle of the lecture, I already explained something. Let's say, I don't know, variables, for example. Open your laptop, write a program that uses, I don't know, like integer variables, floating point variables, something of that sort. And then you write a program that I'm telling you, you upload it, and that's it. 5-10 minutes maximum. Any question? Good. For the midterm, it's 20%, and if you miss the midterm, you don't need to worry. You don't need to do any form or whatever, because usually what I do is take the max of the midterm and the final. So if you didn't attend the midterm, it's totally up to you, but now your final will be 60%, right? So you put more load in you later, right? If you went to the midterm and you didn't do very well, again, don't worry too much, because I'm going to take the max of the midterm and the final, right? For the labs, these are 30%, and the final is 40%. Usually when I say anything about marks, people start talking, right? And these are the important things. Do you have any question? Those who are talking, yeah. Yeah. So I'm going to upload everything to Avenue to learn. Yeah, including the slides with the details. You don't need to write anything, you don't need to worry. The course website and Avenue would be ready tomorrow. I hope so. At least this is what I have been told. So don't worry. Yeah. Yeah, I'm going to mention this. Any other questions? Good. We already explained the quizzes for the midterm. It's going to be on Thursday, October 31. And the time is 6:30 to not 9:30. It's not a 3-hour midterm. But this is the slot that we have been assigned. And it's going to be in these rooms. This is not a 3-hour midterm. There is no need to talk here. Right? Good? Does this answer your question? For the labs, we have 5 labs in total. And again, the way the lab will run is you will receive a set of questions that you have to write programs to answer in the lab. The way any programmer or software engineer would deal in a company, you will get a problem you need to solve, and you write a program to solve this problem, right? The problems will be assigned to you before the lab itself. You go to the lab, it's a 3-hour session, you implement or write your programs, and then before the end of the session, you have to upload this to the Dropbox in Avenue, right? You want to make sure that you deliver your lab on the same session. Otherwise, you will have a late penalty. Any question for the lab? Again, you will be doing the labs individually. My plan is you will have 2 TAs in the lab to make sure that you have enough support. So make sure you ask your TAs during the lab. One thing to mention is you are not allowed to use any material during the lab. Like it's just not open, right? Before the lab, we will provide you with certain material that will help you solve the lab, but doesn't provide anything. Otherwise, if you just leave it open, you can just copy and paste the program from anywhere, right? So make sure you limit yourself to whatever material we provide you for that lab. Good? If you miss one of the labs, for this one you need the absence form, and the makeup will be by the end of the semester, because the lab sessions will be very busy until the end. So if you miss any lab and you have an excuse with this form, we'll be actually doing this by the end of the semester. And the exact dates will be arranged later, early or later November. Good? But my advice is to make sure, unless you have an excuse, don't miss any lab, because labs build on top of each other, right? So if you miss one lab and you don't do it, you go to the next lab, you feel you actually have a gap, right? So maybe you'll need lab 2 for lab 3, right? Maybe not directly, but indirectly. making sure that you have the skill and the knowledge. So make sure you do the lab. Even if you didn't go to the session itself because you have an excuse, try to make the lab like on your laptop, or I'll come into this later, but basically make sure you do your lab before going to the next lab. Okay? For the TA office hours, it will be offered in the same lab, just to make sure you guys don't get confused with 11 different places. So the place where you have your own lab, this is a place where TAs will be there for office hours. The exact hours, again, will be posted in Avenue soon, and this will start next week. If you want to get access to the lab, I guess you guys know where, but I just wanted to write this if someone doesn't know. Okay. For the software used in the lab, and this is something that I actually advise you to do, is in your laptop, you can actually get these tools and start doing the lab at home, or even do some exercises at home as well, right? Something also I do during the lecture is, while I'm explaining certain concept, I'm going to open my laptop in front of you and try to code something, right? Or see with you how the things execute and what is the output. Trying different combinations and try different things and see what is the output, right? Again, this is a hands-on course. The last thing that I want to do in this course is just sit here and talk. I guess maybe this is the lecture where I actually talk the most, right? So I don't want to sit here and you guys just listening and that's it. You are not learning anything by this, right? So I'm going to do certain things during the lecture. You guys also will do this during the quizzes. And you can get the tools to program at your home, and then you go to the lab and also program, right? Again, you try to program all the time to make sure you are good programmers. How to succeed in this course? You have to practice, make sure you solve all the assigned problems to you. We'll also have some references that have so many examples, so if you want more problems, you can actually have this. The good thing is actually programming is almost the best field on the internet where you can get support. You have Stack Overflow, I don't know if you guys are aware about, but basically the internet is full of support for programmers, right? So you can get all set of problems if you want to basically get hands dirty on doing something that is even more complex than this course, right? For the course outline, the course is split into two parts. The first part is C, the second part is Java. The reason for this is these are two different programming languages. C is usually lower level, right? Lower level means it's close to the hardware. It has more details, it's more strict, and usually programmers in C do these things for embedded systems, automotive domains, microcontrollers. This kind of lower level hardware programming is done through C, right? Java, on the other hand, is actually a higher level language. It's object-oriented programming language, so we will learn other concepts that don't exist in C. So we'll learn classes, and then how to inheritance and like polymorphism, these kind of things that you hear about, we will learn in Java, right? So by doing this, you actually get the best of both. You know how to program firmwares or like lower level programming, and you also do object-oriented programming for the higher level. Good? So you can see that like C programming will do this in 5 weeks. How much time we have remaining? Okay. And for Java, we'll do almost like 7 weeks. So it's almost half and half. Any question here? Okay, again, the course webpage will be ready by tomorrow. I'm going to upload this slide and tomorrow's slide on the webpage. And make sure you check the website regularly for like TAs office hours, because we will have many office hours for the TAs, right? You always have, once you start doing the labs, you will have a lot of questions, right? So make sure you go to the office hours and you leverage them. We'll also post some exercises for the lab, some information about this. Lecture notes will be there, practice questions for the labs as well, and some of the past exams before the midterm and the final. For the required text, it's actually not very required, so it's up to you. But basically, I'm going to follow this, right? It's just to make sure you guys have something to go to if you want to know exactly what is my procedure in the course, right? And this is from the previous instructor. Basically, this book is a made-up book, so it's not like an original book. Basically, what happened, what Professor Serena did here is she took some chapters from the See How to Program. Do you know See How to Program book? This is almost the most famous book in C programming. It's called See How to Program. It's a very good book. And then it also, she also took half of the book from the Java How to Program, right? So if for example, you have these two books, that's enough, because the required text is actually just a mix of both, right? And I'm going to mention in each lecture what chapters I'm covering in case you want to go and visit this. Any question? Okay. If you want some additional resources here, I advise you to use See How to Program, Java How to Program most of the time, but if you want further books, in case someone needs them, you have some of these general resources here. My advice to you is you make sure you attend all the lectures. First of all, because this will be your main source of information about the course, about the concepts. And one thing that differentiates an engineer from a programmer in a general concept, because anyone, even if you are in high school or like even if you are in a different field, agriculture or something else, you can learn how to program, right? But the difference between an engineer, software engineer, and a programmer, does someone know what is the difference? Or like have an idea, like imagine, like think of what is the difference between a software engineer and a programmer? Yeah? This is one difference. That's good. Yeah?
The computer scientist is usually more into software.
Can you elaborate more on this?
The software engineers want to plan about like software.
Yeah.
And then the computer scientist actually codes.
Yeah, and right, or the programmers. Yeah, so this is also one difference. Basically, one big difference that I see if you are a programmer and then you are not computer scientist or you are not a software engineer is you know how to do things. Basically, you are a technician, but in programming, right? You don't have the science behind the program. You don't know what are the differences. You don't know your hardware. You don't know if you did something, maybe you focus on functionality, but for example, you just blow away your memory, right? Some programmers do this. A software engineer, as he said, you plan your resources. You know exactly what is your hardware. You know what is your target. So, for example, you want to write a program that takes the minimum time, or the minimum storage, or the minimum memory, right? You have different targets based on the specific problem. For example, if you are writing a program for a car, like self-driving car, or maybe let's say for ABS in a car, you don't want your program to take a minute because you're going to kill your driver, right? So it's not only the functionality that is important, you have other things to care about, you have other constraints. As a software engineer, you take all of this and you know the details of your programming language, and then you write the program that satisfies all of these constraints. As a programmer, and don't worry too much at the beginning, you will be just simply programmers, you just run things, make sure you get the correct result, but later we will see how to optimize, right? So I hope by the end of this course, you also get the skill of how to be an actual software engineer. Like think about other things, especially in C. What is your underneath hardware? What is your constraint of the algorithm? Not just getting the correct result, right? Good. Ask questions. You will see that I always, like every 5 or 10 minutes, I ask you, do you have any question? But if you have any question at any time, just raise your hand. I'm totally open for this. I actually like this. Again, it will give me also some rest. Just talking for 50 minutes is not good. Make use of your TAs. We have 11 TAs. We will have so many office hours for you. What I have noticed in the past is these are not very well utilized, right? Usually utilize these near the midterm or the final. That's not good. You have resources, experienced resources that you can utilize to learn and to make it easy for you to study. To try to utilize these things. Don't wait until the midterm or the final. The course is designed to help you do this because we have labs and you have to get through the lab. And make sure you manage your time efficiently. This is an important thing for an engineer. This is like during the semester and also in your final exam and midterm exam. You will find that time is a big constraint for you. Again, this is the difference between an engineer and someone that is trying to do just hacking what is the exam, what is the problem to solve, and these kind of things. Time will be a big issue if you don't take care of it, especially in my final and midterm exams. Right? Any question here? You guys are good? Do you have any question regarding like the way the course is going to go through like until the remaining of the semester, how to contact me with the TAs and how to find material? Do you have any question related to anything the course? Yeah.
Like about the labs, like is every lab going to be like a testing environment, or are we gonna like learn and then we test it in the next lab?
Oh no, this is a good question. Maybe I just said this in a quick way. So in the lab session itself, you have to submit the lab, right? Don't leave the lab session before submitting your lab because you will be late, right? So the 3-hour session of the lab, basically this is how it will go, right? Make sure it's clear. You have the resources, we'll provide you with some material, we'll also do the tutorial before the lab, so you know what are you going to do in the lab. And you also will help you do some exercises that leads to the lab. You go to the lab, you have specific questions to answer, you have to write programs to answer those before the end of the session. Good? Don't leave the session before submitting the lab. Once you leave the session, you are done with this lab. Next lab will be totally different thing. Exactly. And also at home, you practice all the time. But tutorial is the main source of that. Any other question? Yep. Yeah. So you can have software. I give you examples of the ones that we use. Make sure, if you want, you can have these installed. Install this in your laptop, but you can also have other combiners if you want. But make sure you have this to verify that your program is correct before submitting. Okay. So one last thing, make sure you have your laptop with you starting next lecture because we are going to have a quiz next lecture, right? So make sure you have your laptop with you. Thank you. You are good to go. Specific version. Every decision is with me. Take care. It doesn't really matter much, but okay. So it doesn't state, but I guess the lab will have the most up-to-date one. I guess it's from last year, but you can install the most up-to-date. It doesn't really matter. So yeah, if you want to install this in your laptop, just get like the up-to-date one.
We also want to use it for ADAs in the lab.
Not during the lab, because in the lab you'll be using the lab machine, but in your laptop, do whatever you want.
Are we using Java 8 or Java 11?
Yeah, again, like this is similar to this question. It doesn't really matter much for what we are doing in the course. It doesn't really matter. What version do we have in the lab? I don't recall honestly. I can get back to you. If you are asking like in general, what do we have in the laptop? That's it.
And for C, are we doing C89 or like
C11.
because like some format matter in C89?
That's true.
It does not accept variable declaration type.
Yeah, that's true. So basically my strategy in the course is to make sure I don't touch on the things that mentioned in the version because we don't need them, right? But I agree with you. Like things may work here, may not work here. Maybe the general thing to say is don't use the C++11. Don't do that.
Stick to C89.
Stick to the 89. At least because this is the minimum. Right? The other one has more.
Yeah, more
support.
linear C.
Exactly. Yeah. So, but we don't need it anyway. Right? This is just an introductory course. Right? So we don't need that. So don't worry too much. But
Alright, okay, thank you.
if something like actually matters, I'm going to tell you.
Sure.
So you said open source. Did that include, let's say, an example component for us to test out?
Yeah, for testing. Yeah. But for all labs, I'm not sure. For some labs, I have that.
Because I understand we have to submit it, but at the same time we have to know like
Whether it's correct or not.
it's correct.
You will know, even if you don't get the test cases, because we will like You'll be provided some of those cases to make sure that you
We'll
pass
know,
it.
we'll know if at least we got
You get
most
that.
of the questions.
Sure, that's true. That's true.
Right now, I'm like ordering my laptop. So what about like tomorrow?
Yeah. For this region, you can use paper for now.
Yeah.
And then you just take a back and just do it properly.
Alright.
Basically, what I want to make sure of, even if you write on paper, is everything in one place, like Dropbox, right? So this is why I'm telling you take a picture and upload it after you write the program. The only problem is you cannot test whether you are while you are there. Right? But that's okay, especially for the first 2-3 questions because it's some very simple ones. You don't even have to worry about it. But later, I guess you will be getting that. So don't worry.
Alright.
Yeah. For the permissions one, I have so many of these. So today
I hope you don't mind attending this class.
No. I don't mind. I don't mind.
If you, are you,
I'm going to do this today.
okay, so if you can send me the email, like, I'll send it to Kelly.
Sure. What is your special position like? You are doing? That's why I'm taking it.
That's why I'm doing this course. And I got approved from the USA for all the other forms.
What conflicts do you have with this course, or you don't have any conflicts?
No, I have no conflict.
Oh, it's just because you're in different experiences.
I just need your approval to get into this.
Yeah, sure.
As long as you can get that, I got all the other form ones, and even I have USA for approval as well. So
Today I'm planning
we
to
have a class tomorrow.
Right.
Yeah, I'll attend that.
Yeah, that's okay.
Thank you so much. Since I have a lab next week, so do I just ignore this one?
Yeah. As I said, like labs will start not next week, the week after. That's okay. Yeah, it's a completely introductory course. You don't have to worry. Basically, this is for people who don't have any knowledge before C and Java. So if you have some, it will help you, but if you don't have, there's no harm. These are available, like these are open source tools. You can just, like, if you look for them, like if you Google them, you'll find them. These are very famous. They are available online, so these are open source tools. So you can use them easily. They are also installed in the lab because in the lab room, every desktop has these tools, such that you can go to the lab and do your work. But if you want to get them in your laptop, they are available online. So they are available. Something you can try to do is provide some links to help you. But if you look it up, you'll find them. Yeah, they're free. Yeah.
Unless you're like putting in like. I was wondering like if there's a specific version of C or Java that we need to download, or would any?
It doesn't really matter much. For Java, you can get the Java kit from the Oracle website. Get the most up-to-date one. For C, most of what we do in the lab, we have two main versions in C, what we call C98 and C11. But it doesn't really matter because we don't touch the topics that actually differentiate between both.
Will all this be on Avenue?
Yeah.
Is it possible to upload the
slide?
Yeah, no. The course website on Avenue today instead.
I didn't get the permission yet. This is why it's more of an administration stuff rather than a
understand.
I already sent them a request and then I'm waiting. If it's done today, that's great. If it's not done today,
Another thing I was wondering is that is this course by any chance offered in summer as well?
no, it's not. Thank you.
Sorry, I said the same question.
Okay, the summer one.
No,
the version ones?
Yeah, so
Okay.
we can just find them online.
Yeah, they are online.
Okay.
Yeah.
I was just wondering to see if we can download it.
Yeah, you can download them. And
Okay.
I actually encourage you to download in your laptop because first of all, you can check your syntax and the quiz to make sure you are doing it correctly.
Yeah.
This will help you. And again, you can do the lab in your laptop before you go to the lab.
And then also, does it run on HP, like Windows and Mac, or only Windows?
There are versions for Mac as well.
Okay.
These are very famous tools. They are basic ones. You'll find them both in Windows. And actually, the compiler doesn't matter. So even if you have another based one in case, you can also use that.
Okay.
So,
Thank you.
you're welcome.